Hello everyone, today we're going to be talking about merge sort. And like the binary search, from last episode, we are not actually going to program it because it's very hard to code. We are, however, going to go through what it is because it's quite a useful concept to know. Now, a sorting algorithm will sort an unordered list so that all the content is ordered. This could be useful. So if you need to sort something before you can perform a binary search, because as we found out last episode, binary search can only work on an ordered list. So this is how it works. It basically splits the list up into so that each thing becomes an individual list, and it will then put it all back together as an ordered list. Let's go through it. Let's get a red pen. So let's say, well, we don't need the searching item because it's a sort. It's not a search, so we're not looking for an item. We just want to sort it. As you can see, I've got a random list here: 4, 7, 1, 5, 2, 3. Not ordered at all. Now, what it will do is it will split the list into half. And once it split it in half, it will then separate it into two lists, which derive from this original list. So we will then have. Hold on. Let me just draw out two lists here. We'll then have two lists. And both lists, so the first list will contain these numbers, and then the next list will contain these numbers. I could just select. There we go. There we go, like so. And now we've got these two separate lists. It'll do it again. So now it will split up again. So we will get 4 separate lists. Now, because these are groups of 3, it's not exactly going to be even. But what we'll do is we'll get. So I should probably make that a bit bigger. Now, I'll show you what I'm doing here in a minute. Okay, so now in this list, we're going to have 4 and 7, because it split those up, and because it's an uneven number of items in this list here, it's going to be quite awkward to halve it, so it will just put the 1 on its own. So you've got 4, 7, and a 1. Now, it doesn't matter it's on its own, because it's going to have the same outcome either way. And we'll do the same over here, so 5, 2, and 3. That 5 was terrible, sorry, let me, there we go, 5, 2, and 3. And then it will do it again on that pen, there we go. And now we should, if this has worked correctly, yeah, well, obviously it has, we will have separate lists. So how many items are there here? Well, there's 6. We'll have 6 separate lists, each containing 1 item. So now let's get out our black pen again. So we'll have a 4, a 7, a 1, 5, 2, a 2, and a 3. Now, we'll be able to, what it will do is it will basically re-emerge these into one list. Okay, now the way this works is the 4 and the 7 will come together to make 4 and 7, because 4 and 7 are already in the correct order, so they don't actually need to be swapped around. We'll get a 4 and a 7, like so. So they'll come back together to create a new list. Now we'll look at the 1 and the 5. So we'll create a list out of 1 and 5. Now, sorry if this isn't making too much sense. You may have to rewatch the video a few times or do a bit extra research. It's quite hard to draw live on a diagram while still explaining it. So yeah, my explaining might not be too brilliant, but okay. And then the 2 and 3 are already ordered. So this was actually pretty nice here. So we got a nice ordered list already. So now we got 3. So basically, just merged these and ordered them. So say the 7 and the 4 were the other way around, it would order them down here. So we'd still have 4 and 7. That's just how it works. Now, if we swap back to our red pen, it will combine these two, and this one will still be floating about. So then we'll have 2 separate lists, and let's have a look at this. So the 4, 7, 1, 5, it'll order these. So 1. So we'll look at the first item and then the next. So is 4 bigger than 1? So the first item of the first list and the first item of the second. Is 4 bigger than 1? Yes, so 1 goes first. Is 4 bigger than 5? No, so 4 is next. Then we'll have the 5, and then we'll have 7 here. Now we'll look over here. 2 is 2 bigger than 3? No, so 2, and then 3. And now, oh dear, it will now combine them all together to make one ordered list. So let me get my black pen back out. Not black, sorry. I want the red one. Actually, no, yeah, we'll go for black. There we go, to show that it's ordered. Actually, we'll go for green. Make it nice. Stand out. There we go. And this will show that the list is ordered. And then in here, we'll look at the first item. 1, is 1 bigger than 2? No, so 1's first. Is 4 bigger than 2? Yes, so 2 goes first. Is 5 bigger than 2? No. Is 7 bigger than 2? No. So and then we'll look. So is 1 bigger than 3? No. What's 4 bigger than? So yeah, we know that 3 is less than 4, and then 4, and then it'll go 5, and then it'll 7. There we go. We just ordered it. That's basically what it does. I mean, it's quite confusing, but it works. That's what a merge sort is. This whole thing is a merge sort. This is what a diagram of a merge sort would look like, something like this. And I know it looks a bit confusing, it's not brilliant, but as I say, you might want to do a bit of further research, but that is basically the main concept. I hope you did like this video. I'm going to try to draw a terrible thumbs up symbol here. Yeah, I'm no artist, so make sure to like this video right here. Make sure to hit the subscribe button. Subscribe, there we go. And yeah, thanks for watching, and goodbye everyone.